Hello, my dear students. How are you all? I welcome you all to today's class. I welcome you all to Teacher Dot. I hope you all are doing well. How is your second year classes going on, my dear students? So yeah, I think now we are all have introduced about the chapters that you are going to study in chemistry, right? I think you are thorough with the syllabus, right? What is the syllabus you'll be studying this year? And I think you have all prepared a plan how to get prepared for this second year and how to score well in chemistry. And teacher Dot is always with you to help you for your academic success, students. So I am Meghana, your chemistry teacher. Students, before starting the class, there is a good news for you from Teacher Dot. There is lot of offers waiting for you, students. Please don't miss to grab these opportunities. Fine. So today's class, we will start with an organic chemistry chapter that is very interesting. Alcohols, phenols, and ethers. I hope you all have heard these terms. You know how to identify the functional groups, alcohols, phenols, and ethers, and how to name it. Right? So, we'll be discussing more about alcohols, phenols, and ethers in today's class. Yeah. And yes, also I told you there is a good news for you, right? What is the good news you all are waiting for? Students, Teacher Dot has brought you a very good offer that is just for rupees 10. Yeah, what it is? What do you get for rupees 10? Yes, you will get the entire syllabus lectures, study materials, and all the doubt clearing session just for rupees 10 per day. It's great, right? It's really wow offer, students. See, just a rupees 10 for a day, that means just for 3,650 rupees a year, you will be getting a very regular live classes, all the application based video lectures with animated, with the digital support, students, complete study materials, all the previous year question papers, solving the question papers, doubt clearing sessions. You'll be having a chapter wise tests and assessments. And I'm telling you, this is along with KCET NEET preparation also. It is completely an end-to-end package for your second PUC. Okay, so don't miss this opportunity. Don't wait for a long time, students. Once finish with the class, please go soon and enroll and get the opportunity. Fine. So just for rupees 10, you can log in into the teacher.app. Please download the teacher.app and get all the end-to-end syllabus, materials, and overall preparation, whatever is needed for your second PUC, you will get in a one single app. So it's great, right? So shall we start with today's class? Yeah, alcohols, phenols, and ethers. So let's begin with alcohols. So students, how do you identify alcohol functional group? So if the hydroxyl group, that is OH, just a minute. If an hydroxyl group OH is attached to an alkyl group, we identify it has a compound that is alcohol, right? So this alcohol can be further classified as monohydric, monohydric, dihydric, and polyhydric alcohol. So what do you mean by this term monohydric, dihydric, and polyhydric alcohol? So it means mono means single. That means If a compound contains only one alcohol functional group, we call it as monohydric alcohol. You are familiar with what is this? CH3OH, methanol, yes. What is C2H5OH? Yeah, it is ethanol. So students, here what you observe is each compound, each alkyl group contains single OH functional group. So we classify it as monohydric alcohols. So now you got an idea, right? Can you tell me what is dihydric alcohol? Yeah, as you have guessed, if a compound contains two hydroxyl group, two OH groups, we call it as dihydric alcohol. For example, what is the compound I have written here? Yes, it is ethane 1 comma 2 diol. So this is an so when it is 2 OH functional group, we write it as diol. So this is dihydric alcohol. So if more than 2, when you find 3 to 4 functional groups, alcohol groups attached to a alkyl group, we call it as polyhydric alcohol. So shall I write an example for polyhydric alcohol? Yeah. Students, are you able to name this compound? The IUPAC nomenclature? Yes, it is propane. Since there is 3 carbon atom, it is propane 1 comma 2 comma 3 triol. So this is polyhydric alcohols. Same way, students, in phenols also. When we talk about alcohols, we can classify, yes, we can classify alcohol as monohydric, dihydric, and trihydric. And the phenols also we can classify it as monohydric, dihydric, and trihydric. Shall I write examples of phenols? Yeah. Now let's look at phenols. Phenol means hydroxyl group attached to aromatic ring, right? So it is a aromatic compound. So what is this? Oh, you can see the functional group, alcohol functional group attached to sp2 hybridized carbon. And it is phenol is an example for monohydric compound. Whereas now I'll write an example for dihydric compound. Now what is this? Can you name this, students? It is before naming IUPAC nomenclature, you have to start numbering. Now, I number like this 1, 2, 3, 4, 5, 6, and you find that in the first and third position you can find the hydroxyl group that is attached. So, the name of this compound is benzene 1, comma 2 diol, which is a dihydric phenol. Same way, let's understand the example of polyhydric phenol. So if I write a compound like this, now how do you name this compound? By seeing the previous one, yes, you can name it as benzene 1, comma 3, comma 4 triol. So this is an example for polyhydric phenol. So is it clear, students? Whatever you know about alcohols and phenols, we can classify them as monohydric, dihydric, and polyhydric alcohols and phenols. In the same way, there is one more classification that is very important for you to understand. That is, we can also classify this alcohols, particularly I'm talking about alcohol, students. We can classify alcohols as primary, secondary, and tertiary alcohols. So what is primary, tertiary, and primary, secondary, or tertiary alcohols? So if you remember in your first PUC, you have studied something called primary, secondary, and tertiary carbocation, right? So the same way it is. Let us discuss what is this primary, secondary, and tertiary alcohols. Now let me put some examples in front of you. Okay? Yeah. So try to name these compounds. I'm writing the example. You have to try to name these compounds. Okay? And what is the difference you can observe in all these examples? So what difference you can observe? Students, what you can observe here is here you can find that the functional group, that is alcohol group OH, is attached to, is bonded to sp3 hybridized carbon atom, right? So everywhere you can observe that the alcohol group is bonded to carbon atom. What will be the hybridization of the carbon atom? Yes, it is sp3 hybridized. Whereas in the first example, you can see the sp3 hybridized carbon atom is further attached to one alkyl group. How many alkyl group is it attached? It is further attached to only one alkyl group. Then this kind of alcohol, we call it as, we name it as primary alcohol. So students, what is primary alcohol? The a functional group is attached to sp3 hybridized carbon atom, which is further bonded to only one alkyl group. We can consider it as primary alcohol. Now, same way, what you can observe here in this example, the functional group is bonded to sp3 hybridized carbon atom, which is further bonded to both the side. It is bonded to two alkyl groups, right? You can see two alkyl groups on both the side. Then this is called as secondary alcohol. Now, what about the next example? So you got a clear picture that the functional group is bonded to sp3 hybridized carbon atom, which is further attached to how many alkyl groups? Three alkyl groups. If the sp3 hybridized carbon atom is further bonded to three alkyl groups, we call it as tertiary alcohol. Is it clear, students? So this kind of great explanation of each and every concept will be available to you in depth. It is available in teacher.app. I told you no, it is just for rupees 10. Okay. So we keep on every day you will be having live classes, live sessions, and the complete syllabus. You will recorded class of each and every topics you will find in the app, students. So any topics if you have not understood, or you want more guidance for that, or you want to clear your doubts, so everything is available in a single step, that is teacher.app. Okay, even the recorded topic wise recorded videos also you can find there. Okay, so enroll soon. Okay, so students, is it thorough? The primary alcohol, secondary alcohol, and tertiary alcohol? Yes. Once you have understood this, next what we are going to study, the most important thing is preparation of alcohol. Students, there are various methods how to prepare alcohol, the commercial methods, laboratory methods, or industrial methods of preparation of alcohols. And also exam point of view, there are four methods in your NCRT textbook that is given, and all the four methods are very important exam point of view. Okay, so let us discuss today in today's session how to prepare alcohols by reduction of carbonyl compounds. So what do you mean by carbonyl compounds? Yes, you know, carbonyl compounds means aldehydes, ketones, and carboxylic acid, which contains carbonyl functional group, right? So now what I'm going to do is I will take this carbonyl compounds, that is aldehydes, ketones, and carboxylic acid. and perform reduction. Reduction of the carbonyl compounds will give alcohol. So let us see an example. So let me take aldehyde. So how do I write aldehydes in general? Yes, aldehydes is nothing but R C double bond OH, right? So how to reduce this? Reduction is nothing but addition of hydrogen, right? What is simple? Reduction is very simple. That is addition of hydrogen in the presence of finely divided metals like nickel or palladium or platinum. You can write any one, it is fine. Okay. Finely divided metals like nickel, palladium, platinum, which acts as a catalyst. So it is how to understand this reaction. It is very simple, students. So the product will be RCH2OH. So now you can observe that I had taken aldehyde and after reduction what I got is, yes, I got primary alcohol. Now you will be wondering how this aldehyde is converted to primary alcohol. It is very simple. It is just by addition of hydrogen. And how this hydrogen is added? So it is very simple, students. See, aldehyde has C double bond O. One bond, that is one pi bond breaks and it goes on the oxygen as a negative charge since oxygen is highly electronegative. Got it? Now, what you have to do when oxygen is high electronegative, definitely the carbon will be partially positive charge. So just what you have to do in a simple way, whatever the hydrogen gas we are passing, add one hydrogen to carbon and one hydrogen to oxygen. And now you observe what will be the product you get? It is a very simple way of understanding. So what is the product you will get? Yes, it will be RCH2OH. Is it clear? Shall we look at an example? Yeah. Let me give an example of, let me take an example of ethanol, CH3. Sorry, just a minute. So it's not ethanol, I have to take ethanol, right? Yeah. Or yeah, I can take example of CHO. What is this? Pro Yeah, it is propanol. Now I have to reduce propanol to get alcohol. So let us observe how the reduction takes place. That is by addition of hydrogen in the presence of finely divided metals like nickel, platinum or palladium catalyst. So now I have explained you the simple mechanism of how to understand, right? So what happens? The alkyl part remains same, CH3, CH2. Now what happens to the aldehyde part, that is carbonyl group, this one, CHO, yes, it converts to alcohol, that is CH2OH by addition of hydrogen atoms. So we had propanol and what we got here is propanol, right? Very simple method of preparation of alcohol from aldehydes. Now we shall see one more example of how to prepare alcohols from the next carbonyl compound, that is ketone. Okay, now we shall see preparation of alcohol. I think, did you note down this preparation of alcohol from aldehyde? And what kind of, if you have noted down, just go through that, students, you will see that what kind of alcohol you got. Yes, you got primary alcohol. From aldehyde, what you get will be primary alcohol. Okay. Now let us understand the same mechanism by taking the example of ketones. How do you write ketones? Yeah, R C double bond O R dash. That is two alkyl groups to the carbonyl atom, right? So reduction of ketones by passing hydrogen in the presence of finely divided metals like nickel, palladium or platinum. Because it is same, students, the same like the previous one. As I told you, very simple way of understanding. What you have to do? Add one hydrogen to oxygen atom, which will be negative charge. See, once this pi bond breaks and goes on the oxygen as a negative charge, it will grab a proton. So add one H plus ion to oxygen and add one more hydrogen to the carbon atom. So then what will be the product? Yes, O minus will become OH and one hydrogen to the carbon atom. Yeah, this is the product what you get. Now let me write an example. Let me take a simple example, that is propanone CH3 C double bond O CH3. What is this? Enidu? Yeah, propanone. Correct. Now what I have to do? You have to pass hydrogen in the presence of nickel, platinum or palladium catalyst. Now what will be the product? CH3, yes. Add hydrogen to oxygen, it becomes OH. One more hydrogen here to the carbon, CH3. Now, what you are able to find now, students? What is the compound that you have found? Can you tell me the name of the compound? Can you name the compound, students? Yeah, it is propan 2-all. Yes, propan 2-all. So now it is clear for you how to prepare alcohol from carbonyl compound, that is aldehydes and ketones, right? Now what is the difference you observe in this both? What is the difference? When you take aldehyde and prepare alcohol, the alcohol what you get is primary alcohol. If you have noted down the example, just go through that. Yes, it is primary alcohol. And when you take ketone and try to prepare alcohol, what kind of alcohol you got? It is secondary alcohol. So this point is you have to be very clear, students. Aldehydes on reduction will always give you primary alcohols and ketones on reduction will give you secondary alcohol. Is it thorough clear, students? So here not only reduction by using hydrogen gas in the presence of palladium or platinum catalyst, we can also use very strong reducing agents like lithium aluminium hydride or sodium borohydride. These are the strong reducing agent which will give us alcohol. For example, if I take carboxylic acid, you know that carboxylic acid is also a carbonyl compound. Yes, students, we can convert carboxylic acid to alcohol. Yes, it is possible. So how? Let me take an example of a simple example of propanoic acid now. So you know, right? What is this? It is propanoic acid. Now I'll directly add a strong reducing agent, lithium aluminium hydride. What will be the product when we add lithium in an aqueous medium? Yeah, lithium aluminium hydride is a strong reducing agent which will reduce the COOH functional group, the carboxyl group, to alcohol. That is, we will get the product CH3, CH2, CH2OH. From propanoic acid, what we get will be propanol, the reduction of carboxyl group, carboxylic acid functional group to alcohol. So yes, we can convert aldehydes and carboxylic acid to primary alcohol and ketones to secondary alcohol. Very good method of, very simple method of preparation of alcohol, right? So there are various other methods also, students. So in-depth explanation is given in the teacher.app. Please go through that and find all the supporting lecture videos for your in-depth knowledge. Fine. So now let us discuss about preparation of phenols. How we can prepare phenols in a commercial method or industrial method. How phenols is prepared. Preparation of phenols is very simple. By taking the aromatic compounds, we can prepare phenols. So in today's session, I'll just discuss one method of preparation of phenol and a very good method of preparation, that is by taking haloarenes. So already you know what is haloarenes. So now I'm taking the support of haloarenes to prepare phenol. So which haloarene shall I take now? Yeah, let me take chlorobenzene. Okay. So I have chlorobenzene with me. Using chlorobenzene, I'll prepare phenol. Now, how to obtain chlorobenzene that you have studied in your haloalkanes and haloarenes chapter, right? So if I have benzene with me, what I have to do? Electrophilic substitution, that is halogenation, right? So if I perform halogenation, what happens? You get haloarenes, correct? Now if I have a benzene ring, what I can do? Treat that with chlorine in the presence of anhydrous aluminum chloride, and what you get will be chlorobenzene. Now I have chlorobenzene with me. Using chlorobenzene, I need to prepare phenol. So I'll treat with a strong base NaOH. First, I'll treat with a strong base NaOH, and secondly, on acidification, what I get will be phenol. Okay, students, when you observe this, ನಿಮ್ಗೆ what do you think? ನಿಮ್ಗೆ ಏನು ಅನ್ಸುತ್ತೆ ಮೈಂಡಲ್ಲಿ ಏನಾಗಿರ್ಬೋದು ಇಲ್ಲಿ? What do you think is the electrophiles chlorine is substituted by OH functional group. What do you think usually is sodium and chlorine atom will go out as NaCl and OH is substituted. ಇದೇ ತರ ಅನ್ಸುತ್ತೆ, correct ಅಲ್ವಾ? But no, this is a wrong assumption. Na and Cl will not go out as NaCl. Why? You have studied in haloalkanes and haloarenes chapter that electrophilic substitution in aromatic compound is difficult, correct? So the direct substitution is not possible. So how this takes place? Then intermediate will be formed, that is sodium phenoxide. When you treat chlorobenzene with a strong base like NaOH, what you get is sodium phenoxide, that is O minus Na plus. This is an intermediate you get, and now this intermediates on acidification, Na plus will be replaced by a proton H plus. On acidification, what you get will be phenol. So you should not get confused. An intermediate that is formed is sodium phenoxide. Sodium phenoxide on acidification gives you phenol. Very simple method, right? So using haloarene, that is chlorobenzene, you can prepare phenol. Is it clear, students? Now shall we check one more method of preparation of phenol? Yeah. Yes, you can prepare phenol by cumin. Now what is cumin? Cumin is nothing but it is isopropyl benzene. Let me take an example of cumin, that is isopropyl benzene, and explain you how phenol is obtained from cumin. So students, can you try to write the structure of isopropyl benzene? It is generally known as cumin. Can anybody try to write the structure of isopropyl benzene? Yes, I think you all are trying to write the structure. Isopropyl benzene is nothing but the alkyl group, that is propyl group. The secondary carbon atom is attached to benzene ring. Yes, this is the structure of isopropyl benzene. Now, it is commonly known as cumin. So, using this isopropyl benzene, which is commonly known as cumin, I'm going to prepare phenols. How to prepare phenol? Just treat this cumin in the presence of air. Okay, when you pass air or oxygen, what happens? You get cumin is converted to cumin hydroperoxide. So cumin hydroperoxide. So this is cumin hydroperoxide. So this on treating with any dilute acids, what I get is phenol. Now see, cumin hydroperoxide I got in an aqueous medium. I treat with any dilute acid. Now what I obtain is, see this, the bond breakage here, the bond breakage happens, and see what is the product I get. Along with the phenol, I will get acetone as a byproduct. What is a byproduct here? The bond here, this bond comes here as C double bond O, and it forms CH3, C double bond O, CH3, which is acetone as a byproduct, and the main product will be phenol. So we have taken cumin. Cumin is nothing but isopropyl benzene. Cumin on oxidation, on passing air, we get cumin hydroperoxide. Treat cumin hydroperoxide in any dilute acid, we get the product phenol. So using aromatic compounds like this, we can prepare phenol. And students also, the board exam point of view, all the methods of phenol is very important. There are 4 methods of phenols which I have discussed in depth completely in teacher.app. Any guidance you require, any doubts, you can enroll in the app and clear your doubts. For your complete guidance, a complete uh, for you to be a thorough with the syllabus of your chemistry, especially chemistry, for you to be thoroughly studying this complete year, we will give you a great support. Okay. Now, in today's session, yes, you understood a method of preparation of phenol, one method of preparation of alcohol. What is the one more compound we are going to study in this chapter? Yes, the one more compound, one more functional group that you are going to study is ethers, right? So if you have seen the previous videos, I have introduced what are ethers, how to write the ethers structures, and how to give the IUPAC nomenclature of ethers, right? So once again, if we can recall it, ethers are written as ROR or ROR dash. That means ethers can be symmetrical or it can be asymmetrical, right? For example, IUPAC nomenclature of ethers, that is CH3O, CH3 methoxymethane, or CH3O, C2H5, that is methoxyethane, right? So we have already uh, discussed with in the previous video the how to give the IUPAC nomenclature of ethers. Now once if you are thorough with the naming the ethers or identify ether functional group, next what you have to know is how to prepare this ethers. One of the best method to prepare ether is Williamson's ether synthesis. Okay, it is a very easy and one of the best method to prepare ethers. So we have, and also it is one of important reaction in this chapter. So how do we prepare ethers in this Williamson's ether synthesis reaction is by taking two compounds, two reactants, that is alcohol and alkyl halide. You all are thorough with this to already know what is this two reactants. I have taken alcohol and I have taken alkyl halide. Using these two reactants, I am going to prepare ether. Now first what I'll do is, I have alcohol with me. I will treat this with a strong base, that is NaOH. So what happens when we treat alcohol with NaOH? So the strong base OH minus can grab this proton. It can grab this proton. A bond breakage, cleavage of bond between OH takes place, and the OH can grab this proton and go out as H2O, and we get a product RONA, which is known as, in generally it is known as sodium alkoxide. Got it, my dear students? Alcohol, you know that a cleavage of bond between O and H takes place and we get a product sodium alkoxide. Now next what I do is very simple. Let me take sodium alkoxide and treat this sodium alkoxide with alkyl halide. Okay. So what is the reaction? What reaction happens when you treat this sodium alkoxide with alkyl halide? This reaction takes place through SN2 mechanism. Very simple. What you do is the sodium Na plus and halogen X minus will form a byproduct NaX, because sodium is Na plus and halogen is X minus. And now what is the product you get? Yes, it is ROR. That is nothing but what we were expecting. What we need to prepare is ethers. Very simple way we got ethers. Now, for your clear understanding, let us understand some examples. Now, we shall start with a very simple example now. Okay, we shall start with. So, what is this? Yeah, I told you in general we call it as sodium alkoxide. Now there is a methyl functional group, so we can name it as sodium methoxide. Now which alkyl halide shall we take? Okay, we shall take chloromethane. Okay, now I told you it follows SN2 mechanism, that you have SN2. What is SN2 mechanism? Then I think you have the knowledge that you have studied in haloalkanes and haloarenes chapter. Now the Na plus and Cl minus will be removed as NaCl. And what is the ether that you are getting? CH3O CH3. Can you name this ether, students? Yes, yes, it is a very simple ether, that is nothing but methoxymethane, right? You got methoxymethane. So this is known as Williamson's ether synthesis. Okay. Now let me check how many of you understood this Williamson's ether synthesis concept very well. I'll write the reactants and you have to tell me what is the product that you get. Okay. Now let me take an aromatic compound. What is this? Phenol. Already I explained this. Phenol, when I treat phenol with a strong base, I had phenol, I'll treat phenol with a strong base like NaOH, and what I get is, yeah, I get sodium phenoxide. Yes. Now I have sodium phenoxide with me. I will treat this sodium phenoxide with any alkyl halide. For example, I'll treat sodium phenoxide with methyl iodide. Can you predict the product, students? Can you tell me quickly what is the product I get? What kind of ether will be obtained? Yes, the byproduct will be sodium iodide. And what ether I get? The aromatic ether, commonly known as methoxybenzene, or otherwise sorry, not just a minute. What is methoxybenzene, which is otherwise commonly known as? Yes, it is commonly known as anisole. So we have prepared anisole using sodium phenoxide. Now, what are the criterias you have to know, you have to keep in mind when we are in the Williamson's ether synthesis reaction is the two things you have to know. The alkyl halide, this is fine, the sodium alkoxide part. The alkyl halide what we take should not be, the first thing is whatever alkyl halide you take, it should not be tertiary alkyl halide. Okay, you cannot undergo Williamson's ether synthesis by taking tertiary alkyl halide. And also the second thing, you should not take haloarenes to prepare ethers. Got it? Should be alkyl halide, but it should not be tertiary alkyl halide, or it shouldn't be haloarenes when you're preparing Williamson's ether synthesis. Why? What happens if we take tertiary alkyl halide, or what happens when we take haloarenes? So we will discuss about it. We will discuss in depth about Williamson's ether synthesis in further live sessions and also in the recording videos. Okay. So students, we have discussed a lot about alcohols, phenols and ethers in today's session. I explained you the classification of alcohols, phenols as primary, secondary and tertiary, or how we can classify these alcohols as monohydric, dihydric and trihydric. And I've just introduced some few important methods, very few methods of preparation of alcohols, phenols and ethers. And yes, there are various next what we are going to study in the next live sessions is various other methods of preparation of alcohols, phenols and ethers, some important reaction mechanisms, and what are the physical properties or what similarities this alcohols and phenols and ethers shows. Okay, and also what chemical properties it has, how this alcohol reacts with other compounds, how phenol and ethers react with other compounds, that all come under chemical properties. So next further classes we will discuss with chemical properties also. Okay, so I hope you all enjoyed the class. The concept is very clear to you all. And students, as I told you, the more and more videos and more updates, the regular classes, regular live classes you can attend, and the continuity. I told you, no, organic chemistry, you have to update every day. Every day you should be having a practice. The practice is very important. So whatever the live class or live session or what you see today, you have to practice that. Okay, so regular listening of the class matters a lot. So immediately go enroll to the teacher.app and be active thoroughly, see all the recording videos, go through all the live sessions and attend the regular test and assessments, and that will definitely help you for the successful academic year of your second PUC. Definitely, I'll meet you in the next session with further important concepts, students. And I thank you all for being with me for today's students. Thank you, students. Thank you all.